Hi, I'm Stefan Imler, a research scientist working with NASA's Swift satellite at Goddard Space Flight Center in Greenbelt, Maryland. This is M31, the nearest large spiral galaxy to our own. It's about 2.5 million light-years away and more than 220,000 light-years across. This is how we're used to seeing it, in the visible light captured by ground-based telescopes. But visible light never tells the whole story. So between May and July 2008, Swift's ultraviolet optical telescope captured 330 images of M31 and 3 ultraviolet wavelengths. The total exposure time? 24 hours. We combine these images into this mosaic. It's the most detailed view of M31 in the ultraviolet to date. The first thing you notice is the striking difference between the galaxy's central bulge and its spiral arms. The bulge is smoother and redder because it's full of older and cooler stars. Very few new stars form here, because most of the materials needed to make them have been depleted. In contrast, M31's spiral arms sparkle with dense clusters of hot young blue stars. As in our own galaxy, the disk and spiral arms contain most of the gas and dust needed to produce new generations of stars. M31's clusters are especially plentiful in a giant ring around the galaxy. It's about 150,000 light-years across. This ring of fire exists because of tidal interactions with small satellite galaxies. Speaking of which, this is M32, one of many dwarf galaxies orbiting M31. These galaxies are usually not very bright in the ultraviolet because they lack young stars. But M32's core is so bright in the UV because it likely contains many blue and old stars. The Swift mosaic reveals some 20,000 UV sources. It's important to study star formation processes in nearby galaxies so we can understand what we're seeing in distant galaxies. This rich portrait in 3 different ultraviolet wavelengths allows us to study how M31 stars live and die with much greater detail than previously possible.